So if we go and look at the agenda, so like I said, we have a bunch of things to kind of cover here. First, we're going to go over just some more miscellaneous type enhancements that hopefully will be helpful to everyone. Then we're going to talk about the pre-qualified moment connections per AISC 358. Do some investigate an added feature that we just that we included in 23, which is adding the welds for built-up sections and what actually gets done in the software and where it can be useful. Then we'll talk about the directional strength increase factor for HSS members and kind of when the software uses it and when it doesn't. Then we'll talk about some standoff anchors as far as how the moment is being calculated in those anchors. And then finally, we will talk about something that maybe a lot of you don't know about. It's actually our detail program, which is for concrete. And I'll kind of do a brief introduction of what that is, as well as kind of what was added in version 23. So with that, I'm actually going to just do one more poll. We're a little poll happy today. So this one is just related to whether you do design moment connections, basically using the pre-qualified connections, AISC 358. So if we can go ahead and start to vote on that, and we'll give that a minute just to kind of see what everybody says. So again, about another 15 seconds for this poll. Okay, so we'll go ahead and close the poll. Let me just share so pretty close, nearly 50-50 as far as yes or no. So that's good. So hopefully what Andrea will be showing you in a few minutes will be helpful to you. So with that, I will hand off to Andrea.
All right, thank you, David. All right, so we'll turn off our cameras to start with the presentation over here. And give me 1 sec. All right, so let's jump into the miscellaneous enhancements. Let's start with an interface enhancement. In this new version, the connection items, details, and analysis types can be changed from the design tab. So you will see the name of the connection over here in this new interface when you open any connection. And you can click over there, and then you will see all the details of that specific connection in the file. So now you can change the name, description, design code edition from here. And another important thing is that now the analysis type is selected from this area. So in the previous version, you have, well, if you remember, or if you're still using the software in a previous version, we had all the analysis types over here with the initials of the analysis name. So I believe this is a better way to visualize and make sure what you're analyzing or what type of analysis you're using for that specific connection. And then you can add report screenshots or notes in this area as well. So it is clear, but this is important because I have received some questions about where is that option to change the analysis type and also the design code edition. So just to remember, it's over here, all the details from that connection, right? Then the next enhancement is the report generation. In past versions, every time you click over the report tab, the report started to generate automatically. Now you will see a blank page, and it will ask you to select the settings of the report and then click over the generate button over here, right? So this gives you, like, let's say, more time to firstly select what settings you want in that report and all what information you want to include there, or if you want another type of report. Then Once you're sure of your selection, you can generate, so you don't waste time waiting for the creation of the first report, right? So that's another new thing. Then this third enhancement that I am showing you here is for the working plane operation. The working plane operation, if you haven't used, is a way to create a working plane and cut a plate or member by this working plane. So now you can select the origin of the working plane other than joint. So the working plane now can be referenced from a member or plate. So for instance, in this case, you can see that this working plane was referred to this beam member, okay? And that working plane is located at the longitudinal axis of this member. And then you can also use the coordinates, so you move it from that local axis of the member. So that's useful for cutting another member by this plate, for instance, by this area. And also another situation where it's very useful, where is when you're modeling a bracing element and you have a specific distance from the working point to the start of the bracing. So the working plane operation can be referred to this member, as in this case, this bracing element. And then you input the distance needed in the X coordinate, let's say. So this working plane will follow the longitudinal axis of this member. So then once you input that distance, you can cut the bracing element by that working point, and then you will have it exactly where you want it. So sometimes it's hard to locate the bracing member in the gusset plate exactly where we want, because there is like a gap input in the gusset plate operation that it doesn't really work as we will expect, like it is not from the working point. So this is useful for these cases. So remember, working plane, and now you can select origin, member, joint, or plate. All right? All right, so one of the most important updates for the software in the 23 release are the detailing checks of pre-qualified connections from AISC 358. All right? In StatiCa, it was always possible to model pre-qualified connections, and the modeling wasn't too tricky, as there are simple operations that is the modeling. However, the user needed to double check if the current model was under the pre-qualification limits from AISC 358. So the modeling of these connections were a little bit tedious, because you will need to double check if you were complying with the limits of AISC 358. So how is the current workflow for pre-qualified connections in StatiCa? As I said, you can always model the connection, but now we can code check the AISC 358 detailing limits. So you will see those limits in the screen automatically while you're modeling your connection. Also, another thing is that you can start with templates that we have here, and we have prepared these templates based on the type of pre-qualified connection. So you'll need to select this icon in the class option, then this type of geometry or whatever geometry you need over here, and then you will see all the templates we have for pre-qualified connection. So after that, you can modify members and modify your connection. But you will see the warnings in the model area. I'll show you that in an example. So you can code check these detailing limits before running the analysis. All right? So after you do that, then you can confirm that the plastic hinge location is where you are designing that plastic hinge location based on AISC 358. And how we do that? Well, we do that using the capacity design analysis, right? Where we consider RY and CPR factors for the beam, okay? Again, I'm going to explain this with an example. Finally, you can design all the other components in the joint, like the stiffeners, continuity plates, the doubler plates on the web of the column. You can also design the shear plate that it's coming from the beam to the column. So everything can be designed as well in this workflow. All right. So before jumping into the software, I want to show you that we have three links over here, 3 resource links. I'll post this presentation in the website where you register for this webinar, so you can have access, but this is new content that we have in the website. Firstly, we have a blog post where we kind of introduce the topic, then the theoretical background where you can see what is being checked within those detailing checks. And finally, we have this capacity design tutorial. I'll use that tutorial to show you this new feature in the software. So you can go into that tutorial and download the file that I'm going to use and do the process that I am going to show today. All right. So this is this is the example that I will use. I'll design a reduced beam section connection. Okay. And again, you can download the file from that capacity design tutorial in our website. Okay, so let's jump into the software. Let me bring the model over here. So also let me just show you this tutorial that we have in the website. So this is a steel connection capacity design AISC, okay, tutorial. And then you can click over here and you will download the model that I have here. All right, so the first connection that it's in this file, it just has a stress strain analysis type. All right, we always recommend to do a stress strain analysis type just to check that your connection is okay. I mean, that you can run the analysis, you don't have any issue there. Then the second connection, that it's the one that we will work on, is the same model, but now you can start seeing the pre-qualification limits. Why we have it here and not in the first connection? Well, this is because you need to select the analysis type capacity design, okay, from this area. Remember that we have all the details over here, capacity design. And once you select that, you have check box over here to tell the software that you're designing a pre-qualified connection. The next thing will be to select the moment frame you're designing, if it's a special moment frame and intermediate moment frame. So of course, depending on that, that's what the detailing checks are checked, right? I mean, some limits can change between these two type of moment frames. And this is based on AISC 341. Then the last thing to select is the connection type. Again, there are specific checks for the different connections. So it is important that you select the correct connection type that you are designing. In this case, we have the reduced beam section. That's the first option. That's the one we'll check. So that's why we have here the warnings that I was telling to you. All right. So also in this first step of selecting the analysis type, system, and connection type, the next thing to do is the dissipative item. So you will need to select the dissipative item. So the intention or the main objective of the pre-qualified connections is that our beam fails before the column, right, and the connection. So in this case, we want the failure in this area, in the reduced section, right, of the beam. So how we will tell the software this is our dissipative item? Well, when you are in the capacity design analysis, you will always have this icon over here. And then once you add it here, you can select it from here. So once you select this member, in this case, it's already selected, this member will be increased in its strength, and we'll use the RY factor for this member and the CPR. You can check or uncheck this CPR factor. I mean, if you want the software to calculate it for you using the formula that it's indicated over there, you can have it that checked. If you want to input your own CPR factor, you uncheck it and you input that value over there, okay? So that's the first, let's say, step. So I listed the design workflow over here. Select capacity design, type of moment frame, and prequalified connection, and assign a dissipative item, okay? The next thing is to model and comply with the detailing limits based on AISC 358. So we already have the connection, but we are not complying with all the warnings that we have here, right? The first thing that is showing over here is that we're not complying with the flange slenderness, okay? So if you're familiar with this or not, I'll show you some of the limits we are using over here. So that warning comes from this table where you can see the limiting width to thickness ratios. So that's from where this is going. So what I'm going to do is I'm going to change the profile section for that column, okay? So remember, you can click on Add New, click over the Y flange profile, go to Favorites, and I'll use a 14 by 82, okay? Click OK, and change it to A992. Click OK there. Now, as you can see, once you do a change, let's say complying with the warning, that will disappear, okay? Now, let me also change this name, and I'm going to call it column so we don't get confused, okay? All right, so the next warning to fix is that the weld coming from the web of this beam to the column is, well, shall be CGP, and we have here a fillet weld. So I click over that weld, and you can see this is a double fillet weld. I'll change it to CGP weld. So now we have that erased, all right? And the next warning that we have is the fin plate is 0 inches. Why we have that? Okay, so if you go to the AISC 358 and then you go to the requirements for the RBS, you can see that the design requires this shear plate over here, right? So I'll add an operation, and that will be a fin plate, right? And that fin plate needs to be, well, the thickness needs to be more than 3/8. So, or equals to 3/8. So I'll change this 3/8 over here, okay? Material A36, and I'll use top of steel minus 1.75, okay? So now we can see it over here. I'll delete the gap because that beam needs to be welded as well to the column. So you can delete this gap from here, from the fin plate, 3 inches between the bolts, and I'll use 3 by 3, so that will be 4 in total, and I'll use 7/8 bolts. Oops, okay. So now we are complying with that, so that is also erased. Now, the next thing to fix is that we fail to determine weld axis holes. So again, if you go back to the AISC 358 and see the requirements for this type of connection, you can see that here is asking for a weld axis hole geometry shall conform to the requirements of AISC specification, right? So this is also a new enhancement in the software. So if you go to, well, a new feature in the software, if you go to operation, let's click over here and click over the opening. This is a way to add notches, automatic notches, right? Then let's select the web of that beam, okay? Then let's select the notch option here, and you can see the notch over here. Let me put it in transparent view. It is just in one side. I want it in both sides, okay? And you will need to input, in previous versions, you will need to input that information over here and the rounding radius, and you do your own calculations and input that information over here. But now we have this option to pre-design based on AISC seismic design manual, or AWS. So I'll click on the first option, okay, and that will create the geometry for this, well, specifically for this profile section, okay. So we can do that automatically. And once I added that opening, you can see that we are now complying with all the pre-qualification limits on their AISC. So now we're okay with the second step, model and complied with the detailing limits based on AISC 358. The next thing is calculate the probable maximum moment at plastic hinge, that's the MPR, and the shear force at plastic hinge location, right? So in the tutorial, let me go back now to this, okay? This is a tutorial that I showed you before. If we scroll down here, here is the calculation of this MPR. I mean, in this case, we are using this specific example, but you will need to calculate this. And this is from the AISC 358 design process as well. So you design that, you also design the plastic hinge location, and then from there, you also calculate the shear force at that specific location, right? So that is how we will input that information into the model. So we calculate the maximum probable moment in that position, and then we will input it there in the software at that same position, all right? So that position is where we are planning to have the hinge, okay? That is the center part of this beam, okay? The center of the reduced section, okay? This was already, let's say, designed, right? So how do I know here? Where is that location? So this is 10 inches plus half of the height of this column, that it's 14 inches height. So that is 17 inches. So we already have that value of the moment because I am using the one from the tutorial. Again, you can visit that website and see how that was calculated. The formula comes from the 358 design process. And then you select the beam, okay? And you input that position. So that position is 17 inches, 1 foot 5 inches over here, all right? Again, we are inputting the maximum probable moment over here in this position and the shear force as well in that position, okay? Then the next step, let me go back to the presentation here. We were in this step, so we calculate that moment and we locate it over there. Determine the beam plastic hinge location. We did that because that was already model, and well, the plastic hinge location for that reduced beam, again, it is at the center of that reduced beam section, okay? But that depends on the pre-qualification connection you are designing. It is not the same for all the other connections, okay? The next step is to change resistance factors, okay? Why we are doing that? Well, if you go to the AISC 358, again, let me show you that. And then you go to the design requirements over here. It asks you to use different resistance factors for all the connection design. I mean, for all the other parts of the connection, like the panel zone of the column, all the plates, I mean, the stiffeners or the Doppler plates. So to do the correct design of all the other components of the joint, we'll need to change that in Idea StatiCa, of course. So let's go back here. And then also that is indicated in this tutorial. You can see the instructions over here, okay? It is telling you in the case the design requirements for pre-qualified connection follow this change over here. So you can change that in the code setup here, and we'll change that to 1, right? Except for the fillet wells, we'll use 0.9, and the resistance factor for the material will be 1 as well, following the AISC 358 requirements for all the other parts of the connection. Click OK. So we modify that in the code setup, and finally we run the analysis and verify that the plastic strain, the maximum plastic strain, is happening at the planned location calculated in step 4. That it's the location of the plastic hinge. All right, so let's go back to the model, all right, here, and let's run the analysis. Remember that when we are telling the software we are that this is my dissipative item, we are increasing the strength of the beam, okay, through RY and CPR factors in the material properties of this member. So if we go into the check tab, in this case, what I want to check is the plastic strain, right? So you can see that the maximum strain is happening over here, but we have some plastification in the panel zone, right? So we don't really want that over there. What I am going to use here to push that failure into only this area, because that is expected, that is the objective of using pre-qualified connection. I am going to add some stiffeners in this column. Okay, so I have the final design, let's say, over here. So this is what I add. Also, let's say the modeling requirements for doublers and stiffeners are verified. I'll show you in the report. But when you're modeling things in this connection, and we are under the pre-qualification requirements, you will see always live all the warnings over here. Okay. Anyway, so I input this doubler plate in this web of the column, also in the other side, and then the stiffeners. Okay. I run the analysis. Over here, and then if we go back to the check tab and turn on the plastic strain and the deformed shape, you can see that all the plastic strains are happening in this member. Okay, so that is when we confirm that the plastic strain is happening at that reduced section and not into the column, neither the connection area. Okay, so also when you're seeing results over here in the capacity design, okay, you can see the modified material. So this is the A992, let's say, modified material. And you can see, well, the column is being used A36. You can change it to I992, but the only material that it's modified is the one with the asterisk, okay? So the equivalent stress, the maximum equivalent stress is also modified, okay? And well, we are seeing over here the plastic strain. Probably there are some questions over there. I'll go back to those at the end of the presentation. Okay. All right. So the final step is to review the report. When you create a report of this type of connection, you probably have seen the report over here. This is the detailed one, so you can see the checks over here. But the most important thing, or the new stuff that we are showing over here, is is this table with the limit checks for this specific connection, that it's the reduced beam section. And here you can see all the detailing checks reviewed. and the status of it, reference, and the requirement. Okay. So again, in that in this article over here, we have all the specific checks for the different types of connections that we have over here. Okay, so you can see all we check, and that table can be pulled when you go into the report of that connection. Okay. Again, I'll post all these links into that website, so you can visit this these tutorials and also these articles. All right, so now let's go back to the presentation. Well, the final step was to pull out the report with the pre-qualification details. Okay. Okay, let's jump into the next slide with this the enhancement in the software. Okay, so for selected members in welded or built-up sections, that is when you select a new section, profile section, under this option that it's welded composed. Okay, now it's possible to specify the type of weld between the plates of built-up sections. This is only for the profile section selected in red, in these red squares, just this, okay? And one thing to consider in this new feature is that we are not designing the member, but creating a more realistic model. Why? Because in the past, the connection between plates was totally rigid, right? When you create a built-up section, it was totally rigid connection, let's say a CJP weld, okay? So now with this new feature of adding fillet welds into the connection between the plates, we have a more, let's say, flexible column or more flexible model, right? So this gives us the opportunity to see in a more realistic way how this column will behave. Okay, so when you input that information, well, when you input the fillet welds between the plates, you will see the results of those welds in the same tab where you review the welds for connections. Okay, so for instance, in this case, I create this I section using 3 plates, and I input the weld along this column, right? So if I click over here, you will see the results, same as if you were reviewing the welds from the connection. And then you can see the maximum stresses and the minimum stresses along that weld. All right? Okay, now let's jump into the next one, next slide. In the recent AISC 36022, the directional strength increase factor for fillet welds at the end of rectangular HSS was modified to be 1. Okay, this is following the research project where the behavior of HSS fillet welded to rigid plates was investigated. In the shown link, you will find more information about this study, okay, and how that influenced the change in AISC 360-2022. Okay, so in StatiCa, we implement the new AISC 360-22, and one of the main changes is that factor. So if you model a connection, let's say this is a connection of 2 rectangular HSS branches to Y flange, and then you have that weld at the end of these 2 members. The directional strength increase is not used for those members. So how does this work? So once you have a rectangular HSS member and then you add a weld at the end of those members, that factor won't be used, right? But if you have a similar connection, but that is round HSS or a circular HSS, the factor is still being used. right? Because that, let's say, that elimination of the factor was only meant for rectangular HSS, right? So you can see here the difference between the results, right? It says directional strength increase not used for HSS welds. But here we still have that because this is still applicable for round HSS. All right, let's move on into this enhancement of the moment calculation in anchors with a gap. All right. So when you are modeling base plates and anchors in StatiCa, you can select the standoff to have a gap. So you'll see it like this. That is a gap from the concrete block to the base plate. And you can put that gap over here in the thickness of the gap. Okay. So that's when you have this type of model. So in previous versions, when you select that option of a gap, the bending moment on this area of the anchors, well, on this portion of the anchors, was always calculated multiplying the shear force by the distance between the plate center line and the concrete. So it was just a linear multiplication, like the lever arm by the shear force. Okay. Since this new release, the calculation of the bending moment has been updated. The value is calculated directly by the finite element model, okay? And the anchor is modeled as a beam element. And well, that beam element with this sensor with this height is considering the stiffness of the full system. So we can have a more accurate results when we're calculating the moments. So when you go into the results and then you click over anchors, you will see that moment calculated over here, okay? And again, this is from, well, now is from the finite element analysis calculation, okay? You can see that this moment is also used in the bending resistance design, okay? So the next portion of the presentation will be delivered by David. David?
Thank you, Andrea. Sure, yep.
All right.
Sure, so I mean, this is gonna be kind of the first time we're talking about StatiCa detail here in the in any of the US webinars. So first thing, again, just going to launch a quick poll, and just want to know if you also are involved in the design of concrete structures as well as the steel structures. I know primarily we've been focusing very heavily on steel connection design at this point, but yeah, we do have a portfolio of concrete tools that are primarily being used in Europe at this point. Detail will be the first software we're actually using in the US and kind of based upon the ACI codes. So I'm just going to give it a couple of seconds here to get the responses. Again, I appreciate you answering these polls. They're relatively simple questions this time. So we'll give it another 15 seconds here. Okay, we'll close the poll. And just to kind of let you guys know the results. So about 2/3 of you actually designed concrete as well as steel, which is not surprising. You know, obviously those are the two primary materials to get used on projects around the US. So what is detail? So really detail is primarily meant to design the discontinuous region. So if you look at this graph of kind of a frame, you see all the sections that are labeled as D, whether it be you know, kind of a point load in a typical section, openings, dapped ends, haunches, joints, those types of things are where detail can really come into play and help with design. So kind of a corollary to steel connection design, we're kind of looking at specific joint, areas of concrete structures, not necessarily doing the entire concrete structure. Next slide, please. So again, like we talked about, so this can be used on members. So member openings, frame joints, corbels, walls with openings. So really kind of just for any type of concrete member design, and kind of again focusing on the details. So again, kind of overall checks, strength checks, some anchorage of reinforcement, crack determination, deflection, as well as obviously stresses. So what detail actually does is kind of correlates very nicely to strut and tie method, but using finite element analysis. So this is kind of really kind of taking a little bit extra, kind of taking the strut and tie method out of kind of hand calcs and letting you apply it in a piece of software. So that's just a quick introduction. One thing that I know we've talked to a few of our users about are what we call walking columns. Obviously concrete, for whatever reason, the architects don't feel like you need to necessarily line up every column. So a lot of times you'll end up with these offsets, and you may end up having a section to kind of transfer those loads across. So this is kind of a little test case that we've done as far as with walking columns. So this is something that detail can definitely be helpful with in the future. So next slide. So if we look at what we've done in version 23 to detail, so the ACI code has actually been in there for probably about a year and a half. But what we've done is we've actually added some materials for the US code, based on US standards as far as concrete strengths, giving those stress strain curves in there, allowing you to kind of you have better imperial units, as far as with obviously keeping in with the standards that we have here in the US. As well as kind of adding in some additional templates. So you can kind of see the different beam options that you have as far as for checking, end supports, dapped ends, internal supports, openings, kind of in beams, obviously walls with openings, being able to design that, that information around it, as well as then just kind of frame joints. So that's just a very quick down and dirty discussion on detail, just kind of wet the palate. We are planning on doing a full webinar later on this year on detail. If you have any questions, definitely feel free to reach out to us. So just looking at the questions that were submitted earlier throughout the webinar, not too many of them. One question that was brought up during the pre-qualification or pre-qualified connection check was just that, basically taking into consideration the upper levels of that moment frame, for instance, when we're looking at the doublers and stiffeners. And obviously, yes, you would want to kind of include that in the design, but that would really be kind of initially done in the stress strain analysis more so than the capacity design. Really, the capacity design is meant to evaluate the dissipative item, which would typically be the beam. The pre-qualified joints, that's kind of what, the failure mechanism is supposed to be in the beam, strong column, weak beam scenario. So I hope that answered that question. Just trying to see here.
I am seeing also another one about the rotation level.
Correct.
So that is, I didn't add it into this webinar, but definitely we can do a stiffness analysis so you can evaluate the rotation over there. So that is important. We also can do that stiffness analysis, but you will need to copy this connection and run the stiffness analysis. And again, just to remind you, you can change that from the analysis tab option over here and change it to a stiffness one. All right?
Yes.
What else?
I see that there's a question about the PJP weld design. Obviously, it's not yet in Idea StatiCa. Trust me, this is a conversation I think we have almost weekly, if not more so. It's something that we definitely want to get into the software. It's just we're kind of evaluating how to kind of apply that. So it is something we're looking at. We just don't necessarily have it in the software just yet.
Right, I am seeing another one. It says, I can find the grouping of operations that were supposed to be in 23 version. Yeah, we have that. That is, I didn't add the full, all the enhancements we have in the software for 23 in this webinar, of course, because we just have 1 hour. But please review the release notes of release notes of the version 23. There we have all the information. You will find all the information of the new stuff in this version. But let's go back to the question. And you can now order the operations by right-clicking over the word operation here. And then you can view the operations by operation type or by member. So if I click by member, that will group the operations just for the column, just for the beam, or other operations that are not necessarily assigned to a member. And also if I go to operations again, and I can change it by operation type. So this is, you can see all the cutoff plates over here. And then you can go back to the sequential option. All right, it's there.
And one thing to just note on that, as far as the sequential, a lot of you, I'm sure a lot of you have run into a situation where, the operation has to be above, like if you wanted to use a fin plate or something in another operation, it still has to be in the sequential order. Just because you can kind of reorganize that, it does not allow, unfortunately, it doesn't allow, it doesn't fix that. So you still have to have it in sequential order in order to be able to kind of take advantage of an operation in another operation, if that makes sense.
Mm-hmm.
I see there's a question about detail and whether you can model reinforcement and does it use solid elements. So you do model the reinforcement into detail. So it can be used to help design reinforcement. It is not using solid elements at this point. We're kind of 2.5D. That being said, we are working on making detail a full 3D software. There should be some improvements later this year with version 23.1 to kind of help push that along. But it is kind of more of a 2D solution at this point.
All right.
I'm just seeing the last question there. What's the enhancement in connection detail export to CAD format? Did we make any enhancements for the CAD exports?
Not really, but maybe if you're referring to, every time you run the analysis and you bring the bill of materials, you select this option and then you generate this report, you will have some drawings of some of the operations down here. Let me show you. You will have this, right? All these plates. And then that can be sent to DXF. So you click over here, so that will be sent to a DXF file format, but that's it. And the other thing is that you can pull, you can create a section from this model. Let me just, like this. And then that will create a screenshot with all the dimensions over here. But that's the only thing we have to export. All right.
Other than using the viewer app on the website, where you can generate the connection as a 3D DWG from there. Okay. I'm not seeing any other questions. I guess Andrea did a great job of pushing this through. Hopefully everybody found this very useful. We will be doing another seminar or webinar at the end of June. We're just finalizing the details of that, and that'll be getting out to you in the next couple weeks. But with that, I think we will close the webinar. I appreciate your time. today. And definitely, if there's any other questions, feel free to reach out to IDEA. And have a good rest of your day. Thank you.